Background and rationale of the study. Laser. It is one of the most influential inventions of our century. This technology is an electrical optical device that creates coherent radiation. Application of laser can be utilized for decorative or identity marking of products, precision cutting, and welding. And in manufacturing industry, laser is mostly utilized as cutting tool for different materials, such as wood, plastic, metals, and paper. And speaking of paper, two-axis and three-axis laser cutting machines are the type of machines that exist to cut paper materials. And upon reviewing the published study about laser cutting machines, the researchers can conclude that the three-axis laser cutting machine is more efficient than the two-axis in terms of cutting paper. So this study motivated to innovate a three-axis laser cutting machine. To make this machine more different than those existed, the researchers will make it more intelligent. This machine will have an ability to detect different thickness of paper materials and would adjust the laser cutting parameters automatically. By this way, the user would have to adjust the laser cutting parameters manually and it will reduce human effort.
And the statement of the problem is this study aimed at developing the z-axis of the three-axis laser cutting machine using the Arduino based on controller to address the gaps of the existing two-axis and three-axis laser cutting machine. And our objectives of the study is to develop and innovate an Arduino-based three-axis laser cutting machine that can detect different thick of paper automatically.
Scope and limitation. The researchers began to look for the most possible option on how to enhance or develop the machine. Since the machine can be operated manually and automatically, one of the researchers' idea is to make it fully automatic three-axis laser cutting machine for different thickness of paper. The machine will work in materials like paper and fabric. The study will be limited to three types of paper materials. Regular materials with a thickness of about 0.05 to 0.10 mm. Paperboard with a thickness of around 0.2 to 1 mm. And e-flute cardboard with a thickness of around 1.1 to 1.2 mm. Another limitation also includes when a sudden power interruption occurs while processing with the three-axis laser cutting machine, past execution will be reset.
And the significance of the study, it will give an assistance to workers, student, or even designer who wants to cut complex design in a specific material. Other than cutting it manually with bare hands, which requires more time and the output quality itself isn't guaranteed. In the three-axis laser cutting machine, the user will simply need to input the desired design in the software and the machine software will convert the desired design into data. And the controller will read the transmitted data in and will perform cutting on the material. And the output is guaranteed high quality surface finish with exact, definite, and precise cuts.
The conceptual framework used in the study is the input process output relationship.
My name is John C. Villarino and I'm going to discuss about review-related literature. So in this chapter, it gives us an overview of various laser cutting machines that have been studied by various researchers throughout the world. So laser cutting and engraving machines with 2 and 3 axes respectively, all of the materials that will be discussed are functionally prototypes that have been demonstrated to cut variety of material including papers. This is the 10 prototype that has similarities in our project. So first is design and fabrication of low-cost portable laser cutting machine. Second is design and fabrication of portable laser cutting and engraving machine. Third is solar-powered step CNC machine for fabric and paper cutting. Fourth, design and fabrication of laser engraving machine. And fifth, the possibility of creating a low-cost laser engraving CNC machine prototype with platform Arduino.
And the sixth review of related literature is design and fabrication of three-axis computer numerical control CNC laser cutter. Next is design and development of CNC robotic machine integratable with Nd:YAG laser device. Next is development of portable multipurpose computer numerical control machine. Next is a gantry type of CO2 laser cutting machine. And the last one is manually interchangeable heads of homemade computer numerical control CNC machine. Reviewed of literature summary. The advantages of using a laser equipment over traditional cutting or processing methods are undeniable. However, in reviewing the numerous associated publications, we discovered several gaps that will set our planned prototype apart. Most of the reviewed literature is a two-axis only prototype. Despite the fact that it performed exceptionally well in tests with a variety of materials, even yet, when it comes to cutting different types of thicknesses, the 3-axis laser cutting machine will be more efficient. This research is intended to address all the gaps we found during reviewing the listed literature above. The researchers are motivated to innovate a 3-axis laser cutting machine utilizing Arduino for cutting different thickness of paper materials.
Methodology. The innovation of 3-axis laser cutting machine is divided into two groups: the motion of the X and Y axis and the Z axis including laser. In this chapter, the researchers will present the method used to achieve the Z axis part of the laser cutting machine, including the concept on how the machine will detect the material thickness and exact parameters. The step will start on gathering information, followed by Z axis design, then development and evaluation. Gathering information. The researcher's idea is to detect the material thickness by incorporating sensor to the machine. In gathering information, the researchers will identify what laser and sensor will be utilized for the Z-axis of the machine. Since it is stated in the scope and limitation of the study that the machine will be excellent in cutting regular paper, paperboard, and cardboard, so a 2.5 watts laser will be enough for this type of papers. Then for the sensor, an ultrasonic sensor will be utilized to detect material thickness by measuring the distance. The sensor will be mounted beside the laser head facing towards the working area. The researchers will measure the distance above the working area when there is a material. And when the measured distance detects by the sensor, the controller will adjust the laser cutting parameters for that specific distance. Then for the cutting parameters for paper, such as focal length, laser power, and cutting speed, laser experts suggested that the exact focal length for paper is around 1.5 to 2.5 inches, and laser power is around 10 to 17%, and for the cutting speed is around 20 to 30 mm per second. Z-axis design. As you can see, the sensor mounted beside the laser head, and it is facing towards the working surface. Isometric view of the whole prototype. This is the design considered by the researchers. It has a protective glass and a working table. Development. In this phase, the two groups will start assembling the laser cutting machine. At this point also, the researchers will do experimental study to analyze the exact cutting parameters for the three types of paper stated in the scope and limitation of the study. Once the researchers have analyzed the parameters and other requirements, they can proceed to the implementation phase. Implementation. In this phase, the investigated parameters during experimental study will be implemented to the machine through programming. And speaking of programming, the entire process of programming will utilize the software named Benbox version 3.7.99. Testing. Following to the implementation phase, the laser cutting machine will undergo testing and troubleshooting. The testing will be divided into two parts, unit testing and system testing. And once this step is done, as well as troubleshooting of the machine, the complete prototype will be subjected for evaluation. Evaluation. In this phase, the laser cutting machine will be evaluated by some chosen personnel. The machine's efficiency and acceptability will be evaluated using a 5-point Likert scale. Respondents will express their level of agreement to a statement in 5 points. 1 is strongly disagree, 2 disagree, 3 neither agree nor disagree, 4 agree, 5 is strongly agree to the following questions based on the machine's efficiency and acceptability. After the evaluation, the next step is analyzing the result. This is where the prototype will be judged based on the survey results.